Guys, so let's take a look at C odds. If you did not give me C odds yesterday, that would explain your 0. So if you do have them, turn them in from today. If you already turned them in, here they are back to you.
Is it an option to take the state test early if you have homeless?
It probably is, depending on, I haven't really sat down with him to figure out exactly where he'd be doing that. But I think he is doing it. So it's an option, but it would only be an option like if you had a.
Yeah, I think we would check me, but I don't know. I need to figure out if it's an afternoon or not.
Yeah, figure out
No,
what you
no,
need to do, like if you need to be gone, sure. That's our course.
On the wrong page.
But we're trying to keep that number small,
Yeah.
so unless you need to do it.
That is also in my work.
Yes.
Wait.
Thank you. Yeah. All right, guys, so let me run through the actual solutions real quickly, and then you can ask questions about 1 through 49 odd. So number 1. Yep.
Yes.
State test C number 1. 1 is D, 3 is E, 5 is D, 7 is B.
Wait, can you start over real quick?
Lord. 1 is D, 3 is E, 5 is D, 7 is B, 9 is C, 11 is A, 13 is D. D is in dog. 15 is C. 17 is A. 19 is B. 20.
15 was C.
Thanks, Taylor.
Y'all are like prepared today.
Coming in clutch.
All right, 19 is B. 21 is A.
20. Go back to number 1.
Here we go. 23 is, I don't know, its answer was 12. B. 25 is A. 27 is A. 29 is B. 31 is A. 33 is A. 35 is B. 37 is B. 39 is C. 41 is B. 43 is E. 45 is B. 47 is A. 49 is C. And that is,
45.
say it again, Carson. 17 is A. Now, keep in mind, I'll just go with what you said. Even if you only got 5 on each part, that's 50 points. Plus, if you didn't miss any, which is the tricky part, then that's plus 40 for leaving 40 blank. That's still a 90. And that would probably put you in the top 50th percentile. Even though I never get the scores from everyone, I just get the top 25%. But I think the top 25% was like, for this year, it's like right around 100. So that would require you not missing any, but the goal is just to get better. You know, every test, if you can like learn one little new thing, couple little new things, but that doesn't happen if you don't really look at the keys. Now, I have a key, but I don't want to give it to you tonight because that will deter you actually wanting to do the work. So I'll give you the key to all of them tomorrow, or the solutions to all of them. All right. So in the meantime,
45.
questions. Sorry?
45.
He was ready.
45.
I have not understood that.
Yeah.
Okay, so 45 is saying this. There's a function k that's equal to that. And it says that k was a composition of these other three functions. And you remember composition functions were like f of g of x. Now, a lot of people don't like seeing it like
Is that what
this.
the O is?
That's what the O means. So when you see f o g o h of x, it really means f of g of h of x. So to me, the easiest way to determine this is just to do each A, B, C, D, and E and see which one ends up giving me that. And you can see with B, if I take the h function, which is 5x, that's the first one, right? The h. Plug it into the f function, which is sine, that gives you sine of 5x. And then if you plug all of that into the g, you get the square root of sine of 5x.
Oh, so like G has to be last, like the outermost.
Yes, you start there,
Because it's.
take that, take this, plug it into the g function, and then take what you get from that and plug it into the f function. But that's what the little O means. You can think about it, absolutely.
You just start like, you have to start with the square root because everything else is inside of it, and then.
Yeah, the square root would be the outside function. Sometimes it doesn't work that way because people have simplified.
Right.
But because there was nothing to simplify in this one, you can definitely eyeball that and see it. But if you can't eyeball, like sometimes once you plug in an expression, it cleans up and it doesn't even remotely look the same. So, but you could always just guess and check this way. But I agree 100%. You could look at B and kind of see that. What else? So if you're like, oh, I forgot that about the O. Well, that's just 5 points we just added to your test, hopefully to everybody's test. And if we could do that 3 or 4 or 5 times, and if I had 25 points to each person's test, that's a 100-point jump. That's huge. So that's the goal of this. It's not to, I mean, I realize some of you are looking at this and going, man, I've never placed in my entire life at a math tournament. I don't care. You never know. Sometimes people do have their best showing at this. I had a kid who made a D for me in Algebra 2. A D. But he was actually a decent little test taker. Won the tournament. Won the tournament. And he always was pretty decent, but I mean, he was lazy and didn't do any work, but he could think really well. And it was a really brutal test. I think the high score was a 130 that year. And so it was so hard on everybody that people, you couldn't really memorize your way through it. You had to be ultra creative. And he was very creative. Whatever. So just do your best. I'm not asking for miracles. Just do your best on it. What else?
35.
Okay, I heard 39. 39 says, okay, 39 is pretty tough. Okay, so 39 says, hey, there's this function f of x. All right, I'm going to talk about it and then I'll throw the key up there and let you see it. There's this function here, right, that has this a and the b in it. And they say there are two such pairs, a and b, that make this true. Now, that right there just looks ugly, okay? But what they're basically saying is there's this function that when they did f of 1, they got that. And when they did f of 0, they got that. So I just said, well, let's try. If f of x is that, what would f of x be? Well, if you have an f of f, don't you take that function and plug it back in for x? Okay, so let me just start you with that. This is number 39. Let me show you that. And the math gets kind of wordy, and there is a lot of algebra, and I'm not even remotely suggesting it's easy, but let's just check it out. So the first thing I did is I said, what is f of x? So again, remember, if f of x is a plus bx, then f of x wants you to take that and plug it back into the function for that. So that should give me a plus b of a plus bx. So are you seeing that? I plug the f back into the f, just like we did before with the h and the g, but I'm plugging it back into itself. Now they told me that f of 1 is this. Well, if I want to find f of 1, don't I just plug a 1 in for the x? and I get this expression. You with me? Because the x goes away because it's 1. And that has to be equal to 23 halves. So I have a system of equations. I'm going to have an equation with a and b. And then I know that f of 0 is this. So that means if I plug a 0 in for x, if I do that, all of it goes away, and I'm left with just a plus ba. So a plus ba is what I get when I plug a 0 in, which they told me was 5 halves. Now I have a system. Now you got to be creative, okay? And sometimes you got to be really creative. Now, one way to do it is to solve for a, but you got 2 a's in here, so you'd have to subtract the b squared, factor out an a, or factor out an a. But I just noticed something kind of nice. This a plus ba shows up right here, a plus ba. So I just replaced that with 5 halves, and that left me 1 variable. Does that make sense? It made it really easy to solve that system. Otherwise, it's kind of tricky. Like, for instance, to solve for b here, you'd have to subtract a and then divide by a and plug that in there and there. And then you got a huge mess. Look how nice that was. Replace a plus ab with 5 halves, move that over, solve for b, and I get plus or minus 3. Then I took the 3 and the negative 3, 3 and the negative 3, and I plugged it back in there because that was an easier looking equation than this one. So I plugged the 3 in there and got maximum value of a over b. So once I knew the a and the b, right, there's my a, my b is positive 3, there's my a when b is negative 3, I just divided by a 3, divided by a negative 3, and I got these 2 numbers. And which one's bigger? 5/12. Now that's a hard question. I mean, it really is. It's ugly looking, it's intimidating, it makes you want to crawl in the fetal position. And even if you do know what to do, like I did, it took me 5 minutes, probably kind of playing around and noticing stuff. And my guess is I probably didn't notice that that was an easy substitution until later. I probably tried to do some ugly stuff. So I'm not suggesting that you spend 5 or 10 minutes on every problem, but just to show you that I do any math that you don't know. So that's an example of I'm not afraid of it. Granted, I'm also not on a timeline when I'm reworking these tests Saturday afternoon. You know, when I do that, I'm not on a schedule like, I don't have a 2-hour window like you do. So something like that looks really brutal, you know, maybe put a star by it, come back when you do all the easier ones that you know how to do, and maybe play around with it. But it's not something that's kind of in your wheelhouse. It's not like we spend a chapter doing this kind of stuff. Yeah.
29. What is
Give me a second to find it. Give me a second to find it. 29. Okay, guys, this is just a mod problem. We just did mods.
I know, but I'm saying there was no expert or anything, and there was all the letters. I didn't know what to do.
Okay, now, first of all, this you will never see an easier problem than this if you knew that it was a mod problem. But right here, not to make you feel bad, because a lot of people didn't know how to do this in the other class as well, or didn't get this. But remember what we said? We said normally when we write a mod problem, we write it like this. But these 2 numbers could be switched. So I could just as easily have written it as that. Doesn't matter. And since they asked, what is the remainder? Q is the remainder. Calculate that. Well, that is the Q, right? So this is a bunch of ugly mod question stuff to try to throw you off the track. But bottom line, this is a mod problem. So I just need to, what are the 2 things I do on a mod? You said that there wasn't an exponent. Well, great. I don't need the phi number.
Oh.
Right? But what do I do to always simplify base? Divide by 5 and keep the remainder. What's the remainder?
1.
You're done. That's all you had to do. And ignore all this other fluff, which is essentially defining a mod, right? An operator mod on 2 integers, x and 2016, says that a mod b, 2016 mod 5, will be equivalent to q if the q is the remainder. And literally, when you were solving these, you were reducing, and you were getting that last value. That's the q. But I do realize it's a very wordy way of saying that. Yeah, if you see that, ignore the fluff and go, wait. That's all I got to do.
Number 27.
Sure. So 27. Okay, a lot of people on 27, they looked at that and they went, oh, I don't know trig, so I can skip that stuff. Well, you know a little trig, and you definitely know little logs, right? So let's not be intimidated. especially by that initial thing that said x is a half a radian. Well, we've never even done a half a radian. I mean, we've done half of a pi over 2 radians. When I first saw that half radians, I'm like, I don't know what to do with that. I don't know how to simplify with that. I didn't even need it. Did anybody do this and get it right?
No.
Anybody assume the position? Yeah. Now watch how easy this is. How do you add and subtract logs? You can combine it into one log by multiplying and dividing, right? Now you know that, or you should. So if I have 3 logs, log of blah, log of blah, log of blah, I can combine it into one log by multiplying what?
10x cosine x over sine x.
Whoa. 10x cosine.
Isn't it?
Where are you getting a 10?
10.
Oh, okay. Sorry, muffled voice. Tan x times the cosine x, absolutely right. And dividing it by the
Sine of x.
sine of x. Now, you've learned this. There's a couple ways you can do this, but what is tangent equal to? It's one of the rules on your identity sheet.
X.
Sine over cosine. Now, you can get away with y over x. I'll show you that next. But tangent, sine over cosine. So if I replace the tangent with sine over the cosine, what immediately cancels?
Everything.
And you're left with log of 1,
And that's 0.
which is 0, and you're done. Now, if you didn't remember that rule, you could have said, let's go back to tangent, and then tangent you could have rewritten as y over x. Cosine you could have rewritten as x over r, and sine you could have rewritten as y over r. And if you did that, and you're left with y over r, which still cancels, leaving you with log
So
of
do you
1.
really need anything with the radians, like at all?
Didn't even use it. Again, it kind of threw me initially because I went, wait a minute, there's no pi in there. I'm only used to certain pi values. A lot of people probably took the 1/2 and shoved it in there for x and went, what am I going to do with tan of a half? I don't know how to deal with that. And then bailed. Didn't even need it. Doesn't matter what it is. According to this, the angle is irrelevant because all the trig function, everything cancels. So this is true. Your answer is 0 no matter what x is.
Oh, for number 23, or like in general, but especially for number 23. if you-
Actually, they probably should have said, yeah. And you know why they did say that? Because if they don't say that, then you couldn't say 0 for every value of x, right? Because there are some values of x that could make sine 0. And if sine was 0, you'd be undefined there, wouldn't you? So they just picked a random one out there that wasn't equal to 0 and made it legal. Otherwise, you'd have to say, well, this is equal to 0 as long as sine of x is not 0. That would be your condition you'd have to put on it. But by saying that, sine of a half is not 0, right? Only sine of 0 is 0. Anyway, whatever that's worth. What else?
On number 23, but also just in general, what is an inverse function?
Yeah.
An inverse function is essentially when you take the x and the y coordinates and you switch places. Or basically you take every x, turn it into y, every y, turn it into an x. So when you look at number 23, they gave you this inverse function right here. But they asked you what value of x would make the regular function 52, right? Well, so I need to know what x on the regular function f is 52. And I don't know why I'm saying regular, but just function f. So I need to take the inverse and turn it back into an f. How do I do that? Switch x and y again. So I'm going to replace this y with an x and that x with a y. Now, ignore everything I wrote here. Because really, what is this the second you switch the x and y?
Oh, that's it.
That's the f function right there. It's just not pretty. You don't have to make it pretty. You just have to recognize if that's f, what am I looking for? I want to know what is x when what? When y is 52. Okay. Plug in y equals 52 and solve. And you're done. Square root of 49 is 7. 7 plus 5 is 12. So that's all you needed to do. And look at all the mess I did. I don't know why. Maybe I was in teacher mode. But I went and solved for f and then said, okay, when your f is 52, now solve for x. And then I had to unsolve it again. I had to do the thing there and then all the way back when all I really had to do was use this function right here, right? Because that is the function f. It's just not pretty yet. And the only reason we make it pretty is usually the directions or the answers are in that pretty mode. Like if they said, what's the f function, you'd go, it's that. And you have to go through these steps. But all you had to do is find the x value. What else? That's something we should be able to get. If you missed that, hopefully you're learning from this and seeing it. What else?
35. I feel like it's so easy, I just completely forgot.
Yeah, I thought that it was.
Yeah. I started doing it.
No, it's not. You haven't learned this because you haven't learned probability.
I got a big fraction, but 66 was the little. And I was like, no.
Okay, so I'll give you a crash course, but it's probably not going to help you a lot. All right, so the question is, how many ways can we choose 3 marbles so that exactly 2 of them, you said 35?
Yep. Those are white.
2 of them are white. So if I choose 3 and 2 of them are white, then one of them, you're still choosing 3. What's the other one?
Not white.
Not white.
Or it could be white.
No,
Oh,
this is exactly. So if there's 2 white and you're picking 3, the other one has to be picked. So you would have to have to say that it's a non-white. So the way you pick the count easily, how many ways can you pick 2 whites out of a total of 4 whites is you say 4C2. So the way I would do that, I would say, okay, 2 whites out of 4 would be 4C2. And 4C2 ends up being, well, I wouldn't have probably done, it's this. 4C2 is 4 factorial over the difference, 2 factorial, 2 factorial. And then the way of picking one non-white, well, there's 9 other of the 2 colors that aren't white, and I want one of those. 11 of the other colors. I want to go 11C1. So that is 11 factorial over the difference, 10 factorial, 1 factorial. And that gives you 66. And was the question how many or the probability?
So many.
Oh, it said how many, so I'm done. I have no idea why I wrote probability. Probably because I didn't pay attention. And then I went, oh, I don't need probability. I just need how many.
Oh, I got the thing.
How many is the 66? So all you got to do is multiply this junk out. But again, this will be a shockingly easy question when we get done with probability. We just haven't done it.
Are we doing it after the state tournament?
Yes, we're going to finish up trig, do probability, and that might be it, but I don't even remember. I'll have to go look.
We have more tricks to go.
Oh.
Good stuff.
Sometimes.
Stuff everybody loves.
Is that like
Not
you?
true.
Is that not true?
Yeah. Usually I get this from some people. Man, I love this. And then the people right next to them are like, you're an idiot. Because it's a love-hate relationship. I would strongly encourage you the next section of trig to really pay attention and memorize all your identities early. Okay? It's kind of like this. If I knew all of your faces and all your names the day you showed up here, I could have been having fun with you day one, right? I could have been calling names. You're like, man, he knows my name already. We'd be having fun. It takes a while to kind of acclimate and start enjoying something until you are really familiar with it. And it's like that with this trig stuff. If you wait and go, oh, I memorized it the night before the test, then you just don't recognize it like you do. And it becomes very, so I'd be learning it day one. Anyway, but don't worry about missing that probability stuff. What are we going to do? You know, what else?
Number
what? Number what?
13.
13.
I just also felt like I should know it, but I got it wrong.
Bro, I didn't even try. I just quit.
Yeah.
All right. I knew it.
What was the right answer?
D.
Okay, 13. Let me look at that. It looks like it might be not too bad.
Yeah.
I just looked at it.
So 13 says, oh yeah. Wait a minute.
What 13 are you looking at? Do you see
On
the
the
on
wrong
a date
test.
on a date night, and then you and your date you do.
We're doing, why am I looking at a test E or whatever? Test C.
I don't do this.
Okay, 13. On a date night, you and the date get to choose an appetizer from a list of 3. 2 entrees from a list of 5. And 1 dessert to share from a list of 4. So you're making this choice, this choice, this choice, and this choice.
Is that?
And the fundamental counting principle, which again, you don't know because you'll learn that with counting principles and probability, is if you have to make a bunch of choices simultaneously, not or choices, not like, should I do this or this, but like, I have to pick this and this and this and this, then you count the numbers of ways of doing it and you multiply.
Remember that in 7th grade, if it's and, or if it's or, it's plus.
Plus, if it's and, it's times. So you had to pick appetizer and 1 entree and another entree. And it didn't say that once you picked one entree, you couldn't pick the same one. You and your date could pick the same entree. All right, so I didn't go down. And then and 1 dessert. So because I had to do this and this and this and this, it ends up being whatever that is. 20 times 50, 300 maybe?
So it says, assuming you both order the same entree, like, does that have any?
So no, it says assuming you both could order the same entree.
And so
If it didn't say the word could and it said you ordered the same, then I would just have 1 5.
Or if you had the.
Because that's 1 choice, right?
If it said you couldn't order the same, would the
5, 4.
have to be a 4?
Yeah, you go 3, 5, 4, 4. But again, that would be an easy question. We do probability, and hopefully maybe in the future. But these problems are tricky. I mean, you haven't that not as much as the other one, but the combination stuff. You'll notice you still did the fundamental counting principle, right? Because you counted the way to do one thing times, and then you counted the ways to do the other thing. But it's easier to count with combinations than it is without combinations, right? You right back there? Okay.
Wait, what's the difference between combination and permutation again?
In a combination, the order in which something is chosen or arranged really doesn't have an effect on the outcome. So like if you're playing cards and I deal you 5 cards, did the order in which you receive them really affect anything? Then use a combination. Now, if the order in which you do something does affect the outcome, like if I'm creating a lineup in baseball and I have nine people, or I'm creating a position by position lineup in soccer, right? I mean, putting different people at different positions could definitely affect the outcome, right? Right. So in that case, you would say, oh, if I'm counting the different ways I could do that and the order affects it, then yes, I would use a permutation instead. Well, permutation combinations, the only difference is on a combination like 5C2, you go 5 factorial over the difference, but you also divide by the 2. On a permutation, you go 5 factorial over just the difference.
Isn't it also like, couldn't you just do like 5 or like whatever? So let's say it's like you have a 5 number sequence for a log. Couldn't you just do like 5 little spots and go 5, 4, 3, 2, 1? And if it wasn't a log,
Yeah, but if it's 5P2, you would say it's the first 2 numbers in this. And you can see that there, right? Because if I cancel out the 3, 2, 1, I get 5, 4. So 5P2 is the first 2 numbers in 5 factorial, which is just 5, 4.
Is there any reason you couldn't just do 5 times 4, like 5 for the first and 4 for the second, and that's it?
No. But if the numbers are, if I say 15P7, it's easier to type that in my calculator in real life and get an answer than it is to go, okay, that's the first 7 numbers in 15 factorial. That can be kind of tedious, right? Not that you're going to have a factorial anyway, but I mean a calculator anyway. It'd be something like that. But again, we haven't learned that, so I won't hold you hostage on stuff, certainly, or hold you accountable. Just do the best you can.
Will this be like a grade? Will a state test be like a grade?
I don't grade your actual results and give you a grade for it. I don't, but I give bonus points based on your productivity for the team. So a lot of times if you are in our top 4 scores, I give you bonus points. I give you bonus points for showing up and breathing. I also give you bonus points for being in the top 10. We usually get a couple extra bonus points if we win the state. So there's all kinds of different things. Normally they show up 3rd 9 weeks, but for you guys, they'll show up 4th 9 weeks. So you have out of it. What else you got? Talk to me. I know based on looking at your odds that not everybody answered every question and got every question right. So you're bound to have some questions. Talk to me.
11.
11. So 11 says,
It should not be that hard. I just forgot how to
Yeah.
factor.
I don't know how to factor, man. I'm not gonna.
On the bottom?
Yeah, I forgot how to
You got
do
lucky
it.
with grouping.
it says find the sum of the absolute values of all numbers where f of x is undefined. So where is x undefined? Fx undefined?
Denominator.
In the denominator, if the denominator is 0. So I just set the denominator equal to 0 and tried to solve it. And then when I was done, it said the absolute value of the numbers. It said the sum of the absolute value, not the absolute value of the sum. So I factored it to 4-term polynomial. Remember, we can group it into 2 and 2 or 3 and 1. And usually it's a 2 and 2. So I tried those two and those two. And sure enough, I could take out an x squared. And I could take out a -4. That's the same. So now I take out a 3x plus 5 and join the x squared minus 4, which then factors. And then my roots are -5/3, -2, and 2. That it's undefined, right? All right. And then I just take the absolute value of each, which makes them all positive, and I add them together. But make sure you don't add them first and make it positive, or you get 5/3. So you got to read, it's not the absolute value of the sum, it was the sum of the absolute values. What else? And that is something that we ought to be getting. Okay, so if you missed that because of carelessness, that's okay, but definitely these are things, domain issues, things like that. You have to remember that stuff. We have covered it multiple times. Even though this one might be a little uglier version, it's totally something that we can do. Okay, what else?
31.
31.
Oh, yeah, 31.
So 31, okay. Now 31, we have done some basic ones like this. This is a little trickier, a little longer looking, uglier one. But we did these like first 9 weeks, I think. I know that's a blur back in the blue-red days. But if I'm trying to, let's just say we're trying to solve for A, B, C. If I'm trying to solve for the A and the B and the C that makes the right side equal to the left side, then what they're essentially saying is it doesn't matter what x is. Doesn't matter. So, but I don't really like the way it looks right now. What don't you like about it?
Fractions.
The other class is like, I hate 7s and 13s. I'm like,
That's a good point.
what?
That's valid.
Fractions.
Why would you hate the luckiest and the unluckiest numbers? They're interesting.
They're evil. They're hard to work with.
Seven's
Seven.
lucky.
Seven?
Lucky.
Seven's lucky. 007, James Bond. I actually parked in the 7 parking space for like 22 years. Then they moved me. I'm like, no, it's lucky 7. Anyway, what could you do? What do you think that's ugly about this expression? I think the fraction. And then when I look down at the fraction, what do I see? The common denominator is that. So what if I just multiplied both sides by those two factors? What would happen on the left?
It just becomes 7.
All goes away. What happens to this one? You get A times the trinomial, and then on this one you get bx plus c times the binomial. So that's where I'll pick up. So that's where we are. What number is this again?
31.
That's where we are on 31 here.
Plug in.
So here we go. Once I do that, I have this expression. Now remember, it has to be true for every value. So my thought was, well, why don't I just pick a value of x, anyone, and plug it in there? But if I'm really wise, I'll pick a value of x that will cancel a bunch of crap out. Now, you might think, oh, 0 cancels a bunch of junk out, and it does. But what's even better than 0? How about 2? If I plug a 2 in, this becomes 0, and all of the b and c go away. And the only variable I'm going to have left is a, and I can solve for a. So I plugged 2 in, there, and got 15. There, and got 3a. And there, and all of that canceled. And I can quickly solve for a, and now plug it back in there. So I've got my a. Now, The bx plus c is a little trickier. So what could I plug in now that might at least help me a little bit? Well, I thought, why not 0? Because 0 is going to clear out all the x's, all of those x's, and the b leaving me just what? C. So let me do that. If I let x be 0, I get 13 equals 5 times 3 plus c times -2. And I can easily subtract 15 and divide by -2 and get c. And now I have c. And now it doesn't matter what you plug in. There's only x's and b's left. So any value of x is going to leave you with b. So why not plug the easiest x there is, which is the smallest integer we have to use, which is 1. So I plugged the 1 in there and got 7 minus 13 plus 13, 1 minus 2 plus 3 times 5, and then b plus 1 times -1. And then I just cleaned it all up, distributed, added like terms, and got b equals 2. And at that point, I can multiply and get 10.
So how did you know that any value of x is right?
Because it says they're equal. It says the left side's equal to the right side. Now, normally we're trying to solve for x, right?
Yeah, that's
But I'm not solving for x. I'm solving for the a, b, and the c that make this true. So if I can find the a, b, and c that makes it true, then I have to assume it's true for every value of x, with maybe the exception of some undefines. But that's why I turn it into this real quickly. Because if I don't change the undefined thing, then I can't use 2 and I can't use 0, maybe some other things. But if I rewrite it like this, I'm able to use those values, any values I want. Works nicely. And if you're wondering why does this kind of problem exist, in calculus, somebody's going to come along and ask you to integrate in BC calculus. Somebody's going to ask you to integrate number 31 right there. And you're going to go, I didn't learn how to do that. Nobody will ask you an AB, but like if you take BC and Helmer's teaching it, he'll ask you to integrate that and you're like, I can't do it. So what you do is something called a partial fraction decomposition. And you'll actually learn strategies in the pre-cal class, math team pre-cal, how to rewrite this as that. Like you'll learn some strategies on how to choose A, B, X, and C. And then once you choose them, you'll take what you learned in Algebra 2 here and solve for A, B, and C. And then this fraction now becomes this one. And even though integrating this fraction I can't do, I can integrate those two fractions. And you haven't learned integration, so that means nothing to you. But you with me? But anyway, this is just real basic stuff on the front end so that when they get the partial fraction decomposition in pre-cal, you'll go, oh yeah, I kind of remember that. And then when you get to integrating these kinds of things, and Homer throws that out, he'll probably go over it if you're in BC. But when he goes over it, you're like, oh yeah, I remember Hurry talking about that, assuming he was here next year. What else you got?
You do 17.
17. Okay, 17, guys. Let me just show you the strategy. This is not an easy problem, but I'm going to try to make it easy for you.
I got a -13.
I got,
Wait a minute, 17.
yeah.
How'd you get a negative?
Okay, so here's what I did.
That was wrong.
Hey, guys, here's what I did. I looked at this and I went, man, I guess I could factor it, but it looked a little ugly like this. So I did this. I let A equal the absolute value of x plus 3, so it would look like this. Is that a little easy to factor that way?
Yeah.
A plus 9, A minus 2, right? So you end up, if it's A plus 9, A minus 2, you end up getting A equals -9, and you end up getting A equals 2. So here's where my work picks up on 17. So as you're doing this, if I just let A be that, you don't have to, but if I do, it looks a little better. I can go ahead and solve for A and then plug the x plus 3 and the absolute value back in. All right, so at this point I go, wait a minute. Can the absolute value of anything equal a negative? So I toss that. And then I go, all right, can I solve these? Sure, we learned it the first week we were in this class. Well, maybe not, because it was a little, times were difficult back then. But remember the rule on absolute value? Sometimes it's positive, sometimes it's negative. And then bring down the equal to. And if it was an unequal, if it was a less than, you put less than, and put an and. If it's a greater, you put greater thans and put an or, and you solve. Remember that? Less than, greater. You didn't have to do that because it was an equal. So you just brought down the equals and solved. And the question was, what is the sum of the solution?
Equals that -9.
I got -13 somehow.
You know, I think I might have too.
Now, you might have done this.
No, I got 0.
X plus 3 equals -9, negative x minus 3 equals -9.
I didn't do the A, I just did regular old completing square and factoring and.
Now, that would have given you just another negative. I would have given you -12. Did you make it -12? That I'm guessing?
Get rid of the 9.
Did you get rid of that one? Yeah.
On,
Well, again, you learned something. You won't make that mistake again, hopefully, and you still got pretty far on those. What else you got?
37, I think. I know, we know how to do that. I just forgot. I need to be reminded.
On the same amount of like miles. You could just do it.
No, that's the same amount.
Okay, so 37. They didn't ask me about that one.
Same distance.
Man, did I not?
R,
Did I do it again? Please let me hit record.
Oh, no.
Oh, no.
Good.
Yeah.
All right, I forgot to record the other class. All right, so 37, right? Claire's on a bike ride. She bikes uphill 4 miles at a rate of 8. Another distance and a rate. What was her average speed on the trip? So I just said, what's average speed defined as? Average speed is defined, since rate, if D equals RT, rate is D over T, right?
Oh, it's a dirt.
And isn't average rate the total distance divided by the total time? So all I got to do is take the total distance, which is 4 and 4, and take the total times, which I don't know. So to find each individual time, what do? D over R. So each individual time would be D1 over R1, D2 over R2. So I took, again, D1 over R1, D2 over R2, and added up those 2 times. And at that point, I'm just doing math. So the closest one would be 11. The answer is 10 2/3. Or, what do we know about average rate? 2 times the product over the sum, the individual rates.
That's, I know the distance.
And that's much easier. That's when the distances are the same, and they are, right? 4 and 4. So if you know that, 2 times the product over the sum, much easier to get to 10 2/3, which is approximately 11.
You do, I don't know what time it is. Number 1.
Number 1. So number uno.
I actually got that.
I don't know how I do.
So number 1 says find the slope of the line between those points. So I have to go y minus y over x minus x. So I take the one y value, doesn't matter which one, and subtract the other. And I take one x value and subtract the other. Now that's the slope, but we can't leave slope like that. So I've got to now do what? I got to multiply by the conjugate at the bottom. So now I've got to take that and FOIL it all out, which is a little bit of a pain. So root 6 times root 3, root 6 times a regular 2, negative 4 root 2 times a root 3, and then negative 4 root 2 times a positive 2. And on the bottom, because those are conjugates, I don't have to FOIL them. All I got to do is full one. So first, last, 3 minus 4. So when I go to clean all that up, it doesn't clean up supremely well, but it cleans up okay. So I can subtract the x terms. I'm sorry, I can subtract the, that's the same thing as 3 root 2. So I can take the 3 root 2 and the negative 8 root 2 and get negative 5 root 2. I can take the 2 root 6 and the negative 4 root 6 and get negative 2 root 6. And the bottom's negative 1. So at that point, I just multiply the top and the bottom by a negative. And got 5 root 2 plus 2 root 6. So a lot of little algebra going on there. But
5.
but doable. 5 says the
Yeah.
equation blah has 2 solutions. So on 5, I said, what are they? So the first thing I did was add 2 to the other side to get an 8. And then I'm like, all right, how do I get rid of a 3/4 power? raise it to the 4th power first. That gives me 2 cubed to the 4th. You could do this in one step, and let me cube root it to get rid of that. So I cube rooted it. And to do that, the cube root of 2 to the 12th is the same thing as putting that 3 under there and making it 2 to the 4th. Now, honestly, I don't know why I did that. I don't know why I just didn't do 4/3 power on both. And just get rid of it in one fell swoop. And if you do that, you could take the cube root of 8, which is 2, and 2 to the 4th is 16, and you would be done with that part. So then I subtract 16, factor, and get my 2 solutions. And it said, what is the sum of the squares of both? So that was it. Now, there's a rule to get the sum of the squares of the terms by just looking at this right here. But the problem is usually they say stuff like sum of the squares of the real numbers, and you don't know what's real until you solve. So
Anyway, it's worth for you to like go all the way through.
On 47, like, don't you have to find the vertex for that? Because it's like,
Oh, yeah, I forgot.
how, what is that formula again?
let me look at it.
It's a profit function.
Mr. Hurt, go
Yep.
to the restroom.
Sure. It says find the max. Oh, so you're finding the maximum value on the parabola? So I just completed the square, and that's not necessarily the easiest way to go. But do you remember another way?
Can't you do like negative 3p over a?
Yes. No. Negative b over 2a.
Oh, that's how that's done.
So if you were to look at 47 and go negative b gives you this, twice a gives you this, and you get 23,
Oh, yeah, that's.
and then you just plug the 23 back in and get your y value, and that's the max. And be careful, because if the parabola is going up, then there wouldn't be a max. So sometimes they'll say find the max, and you'll do this and plug it in there and get 169, and you'll go, there it is. I'm like, that's the min. So you got to make sure it's going down, but you know it's going down because it's a negative x squared. What are you thinking? Feel like you're learning something? Okay, that's the goal. Don't look at this and like, man, I'm never gonna win. You never know. You don't. And again, it's bonus points. Getting that top 10, top 4 or 5.
How long are you getting those shows?
I don't have no idea.
I'm just looking.
Truly no idea.
You know what, I'm not gonna answer. What?